Swayam Prabha. Digital India. Educated India.
Now we look at power and energy in an independent current source. Current source maintains a current of I naught regardless of the voltage across it. This is the voltage across the current source, this is the current through the current source, and the power as usual is the product V times I. Now, the IV characteristics of a current source are like this. I have assumed that this I naught, the value of the current source, is positive, but of course, it could well be negative. So, as before we see that in the first quadrant where the voltage and current are both positive, the current source absorbs power, whereas in the second quadrant where the current is positive and the voltage is negative, the current source delivers power. Similarly, if we took a negative valued current source, let me call this I naught prime, then in the fourth quadrant where the current is negative and the voltage is positive, the current source delivers power or it absorbs negative power, and in the third quadrant it absorbs power. So, just like a voltage source, a current source can either deliver or absorb power. Okay. So, it can deliver power. So, it is also not passive. Okay. Now, the case of the current source is quite similar to that of the voltage source. I will still show an example. Let us say I have a 1 milliamp current source connected to a 5 kilo ohm resistor, and as before I will choose VR and IR as voltage and current of the resistor according to the passive sign convention, and V1 and I1 of the current source according to the passive sign convention. So, it is quite obvious that 1 milliamp flows through the resistor, 5 kilo ohm resistor. So, a voltage of 5 volts appears between these terminals, and from this we know that V1 is 5 volts and this current I1, which is opposite in direction to the current source direction, I1 is minus 1 milliampere. So, their product P1, which is V1 times I1, is minus 5 milliwatts. And as far as the resistor is concerned, VR is 5 volts and IR is 1 milliamp, and their product is 1 milliamp times 5 volts, which is 5 milliwatts. So, the current source in this case, this is delivering 5 milliwatts or absorbing minus 5 milliwatts, and the resistor is absorbing 5 milliwatts. Okay. Now, as with the voltage source, if you have a single current source connected to a resistive network, then this will be delivering power, because that is the only source of power or energy in the network. On the other hand, if you have multiple sources, and I will show both voltage and current sources. If you have multiple sources connected to a network with only resistors, then some of these sources could be absorbing power, and at least one of them would be delivering power. Okay. So, this is very much possible. Let us take a simple example of a 5 milliamp current source in this direction in parallel with a 2 milliamp current in the downwards direction connected to a 10 volt voltage source. Okay. So, again I will formally define currents. After a while you can do this almost automatically. V1 I1, V2 I2 and V3 I3. Okay. So, first of all, simple circuit analysis, basically Kirchhoff's current law tells you that here we have 5 milliampere due to this current source, and here we have 2 milliampere due to that current source. So, that means that we have 3 milliamp going that way. So, from this we know everything, and of course, these three elements are all in parallel. So, across all of them we have 10 volts. So, V1 is 10 volts and I1 is minus 5 milliamperes. So, the first current source, the 5 milliamp current source is absorbing a power of minus 50 milliwatts, that is minus 5 milliamps times 10 volts. The second current source has also 10 volts across it, and V2 is 10 volts and I2 is plus 2 milliamps. Okay. That is clear from this direction, and P2 it is absorbing a power of 20 milliwatts, and finally, the voltage source has a voltage of 10 volts V3 and a current I3 of 3 milliamps. So, it is absorbing 30 milliwatts. Okay. And again, as before, the sum equals 0, but for us now we see that this is delivering power and these two are absorbing power. Okay. Just like a voltage source, a current source can absorb or deliver power. Okay. And in this example, we have three independent sources. One of them happens to be delivering power and the other two happen to be absorbing power. Okay.